We also now know that Saturn is orbited by over 60 natural satellites. The largest of Saturn's satellites is a moon called Titan. It is enveloped in a thick atmosphere, one filled with orange haze. In 2005, a NASA probe penetrated the veil of mystery and sent back the first images of the surface. The terrain looked amazingly familiar. Black lines branched out over the surface. They looked just like rivers. And numerous lakes were discovered. This was the first time any celestial object had been found with liquid on its surface. The more the probe investigated, the more Earth-like Titan seemed to be. It was at this point that scientists began to suspect that life might be present.
Maybe in the seas, more interesting things happen. Maybe you get self-replicating chemical systems, much like those that are the first steps towards living systems that were deep in our own history. So Titan gives us a whole new set of possibilities.
There's the possibility that maybe there is life on Titan that has somehow found a way to make use of all of these building blocks that the atmosphere is making for it.
However, the temperature on Titan is minus 180 degrees Celsius. Could life really exist there?
Well, how do we know it's too cold? Imagine you're living on Titan and you're looking at the Earth. You'd say, oh, there's a liquid, there's organics, there's energy, but it's too hot.
Titan has both an atmosphere and liquids. Could life exist there? This planetary body, very similar to Earth. Saturn's moon, Titan. Imagine the journey from Earth to Titan. If you could travel at the speed of light, you'd pass Mars about 4 minutes into the voyage. At the 30-minute mark or so, you would pass the giant ball of gases known as Jupiter. Then, some 70 minutes after departure, you would finally arrive at Saturn, surrounded by those beautiful rings. Like Jupiter, Saturn is a large, gaseous planet. Finally, you'd reach Titan. With a diameter of 5,000 kilometers, Titan is about 3/4 the size of Mars. It's a moon the size of a planet. Fully cloaked in that orange haze, Titan's true appearance was not known until the 21st century. (1997) saw the launch of the Cassini-Huygens mission. The Cassini orbiter, equipped with cameras and other instruments, and carrying the Huygens probe, was sent to investigate Saturn and its moons, especially Titan. In 2004, 7 years after liftoff, Cassini-Huygens reached the vicinity of Saturn, 1.4 billion kilometers from the Sun. Cassini then proceeded to enter into orbit around the planet and its satellites, and to commence scientific observations. It took this image of Titan. For the first time, Titan's true features began to show from under that thick haze. The day was approaching when we would finally be able to see the surface of Saturn's giant moon. In December 2004, the Huygens probe separated from Cassini and coasted to Titan. The target landing site was near Titan's equator. What that site would be like, no one knew. Titan's atmosphere is 1,000 kilometers thick. The probe entered it. Huygens deployed a parachute and drifted down, jettisoning its heat shield. This image, taken from a height of 152 kilometers, was Huygens' first view of Titan, which was still obstructed by haze. Huygens was shooting still images as it descended. Its microphone also captured the sound of the wind rushing by. This was the first sound recording ever made of an alien environment. These images of Titan's surface were taken by Huygens from 16,000 kilometers up. Black veins, like the branchings of a river, are visible. It does look as though they are flowing to the mouth of a river. Now, from 8,000 meters above Titan, it looks just like the sort of coastline we're used to seeing on Earth. Finally, the landing. This is an image taken by Huygens just after landing. What look like rocks and pebbles strewn about over a flat plain are actually chunks of ice. The surface temperature is minus 180 degrees Celsius. Atmospheric pressure is a little higher than Earth's, 1.5 bars. The horizon seems blurred by mist. This is exactly like some rocky desert landscape on Earth. High above, the Cassini orbiter continued its observations. In the equatorial region where the Huygens probe landed, Cassini discovered a strange pattern. Some sort of regular striping. Further observations found similar striations covering some 20% of Titan's surface. Ralph Lorenz has dedicated himself to investigating this strange striped pattern. He is trying to solve the mystery of Titan's stripes by comparing them to patterns he finds on Earth. This is the Mojave Desert in the western United States. Lorenz believes Titan's stripes are like the peaks and troughs of desert sand dunes. There are indeed real similarities.
It's remarkable somehow that despite the different gravity, the thicker atmosphere, and the different material that the sand is made of, somehow the landscape ends up looking almost exactly the same as many places on Earth. By comparing the shape of the dune and the interaction with the rest of the environment, we can get an understanding of how these structures formed. And for example, different shapes of dunes form in different wind patterns.
So the goal is to solve the mystery of Titan's stripes by investigating terrestrial desert dunes. Lorenz's first step is to send up a kite with a camera for an aerial overview. He's looking for a place that has a striped pattern like Titan's. Next, he mounts a dune buggy equipped with GPS. He wants to measure the heights of dunes and the angles of their slopes. The shapes of sand dunes change by the minute. Lorenz plants a stake with a streamer attached. In fact, he plants a whole line of them along this slope. This will show what sort of wind creates this type of dune. The wind is blowing from screen left, across a gentle slope. Then it swirls around, as if to carve out that slope to the right. So it's become clear that here the wind flows from the milder slope over and down the sharper slope. Lorenz believes that the stripes on Titan are also wind-sculpted sand dunes. A closer look at that image of Titan's stripes shows ridges with milder and sharper slopes, similar to those in the Mojave Desert. So Lorenz conjectures that the wind on Titan must have been blowing from left to right. The winds blowing on Titan's dunes, however, are thought to be weaker than the winds on Earth. The reason for that is that Titan's gravitational force is only 1/7 of Earth's. A relatively small action can produce a big result. So on Titan, effects similar to those seen on Earth are being produced by mild winds.
Titan is still an active world where, geologically speaking, processes are still happening. And the fact that we can see sand dunes, for example, suggests that the winds that move the sand around are still active, that we're seeing a dynamic planet, much like the Earth.
There was another unexpected aspect to those images taken by Huygens. Look closely at those chunks of ice on the ground. They are reminiscent of stones turned over and over by rivers on Earth. Sharp edges are worn down. They're rounded, like pebbles. So there may well be liquid on Titan. This discovery attracted attention and astonishment. Meanwhile, the Cassini orbiter made a surprising discovery of its own. Black spots and blotches were visible near Titan's north pole. Radar observations showed them to be lakes, filled with some liquid. They number in the hundreds, and some of them are huge. This is the first time liquid has been found on the surface of any celestial body other than Earth. The lakes are dotted with islands and fed by rivers. But with a surface temperature of minus 180 degrees, any water on Titan would have frozen. What liquid could it be in these lakes and rivers? This is it. Liquid methane. On Earth, it's normally a vapor, but at extremely low temperatures, it condenses into a liquid. Methane melts at minus 182 degrees Celsius. It boils at minus 161 degrees. In the 20-degree range between those two extremes, it exists in a liquid state. The temperatures on Titan's surface are just right for liquid methane. Methane is composed of 1 carbon atom and 4 hydrogen atoms. It's the simplest hydrocarbon, and it constitutes the bulk of the liquid in Titan's lakes. A portion of the liquid is ethane, another hydrocarbon with similar characteristics. Scientists at the Jet Propulsion Laboratory are trying to determine how Titan's methane lakes were created by conducting experiments here on Earth. Christophe Sautan is an expert on bodies of ice found in the solar system. This device is called the Titan chamber. With internal air pressure at 1.5 bars and a temperature of minus 180 degrees Celsius, it reproduces Titan's environmental conditions. Inside is placed a disk of ice, standing in for the terrain on Titan. They then release droplets of liquid methane onto the surface of the ice. The methane disappears immediately, absorbed by the ice, like water being swallowed up by a thirsty earth.
So the big surprise, something we did not expect, is that when the methane falls on the ice, actually the methane got sucked into the ice. It gets absorbed. It doesn't run on the ice.
However, if methane continues to drip onto the ice, eventually it begins to pool on the surface. This suggests that wherever there are lakes on Titan, the surrounding ice must be saturated with methane. During its landing on Titan, Huygens measured the concentration of methane. That concentration gradually rose the closer the probe got to the surface. Then, the moment it landed, there was a sharp increase. It is thought that this was due to the heat from Huygens vaporizing the methane that permeates the ice. On Titan, liquid methane acts in ways similar to water on Earth. In June 2012, for example, Cassini observed a strange phenomenon near Titan's south pole. An oddly shaped mass seemed to be squirming about in the atmosphere. It was a cloud, swirling. A cloud made up of methane. On Earth, water is recycled as water vapor and rain. One of the factors prompting this is seasonal change. On Titan, the same sort of mechanism seems to be at work. Titan is tilted on its axis, some 26 degrees off vertical. The Earth has a 23.4 degree tilt. It's another point of similarity. Along with its parent planet, Saturn, not shown here, Titan takes 30 Earth years to orbit the Sun. The tilt of its axis gives birth to different seasons. At this location, Titan's northern hemisphere experiences the long days of summer. The northern hemisphere is warmed, producing rising atmospheric currents. Liquid methane on Titan's surface evaporates and is carried southward. Near the South Pole, it is winter. The methane gas is cooled, condensing into a liquid or even solid state. It can form clouds. Like that huge swirling cloud Cassini spotted. When it's winter in the northern hemisphere, the cycle reverses. Now the methane cloud forms near the North Pole. Underneath that cloud, methane rain begins to fall. Since methane is more viscous than water, its raindrops are larger, with diameters of about a centimeter. But as Titan's gravity is weaker than Earth's, the droplets fall more slowly, about 1 meter per second, like a soft snow on Earth. They soak the icy ground on Titan and form lakes. Wind blows, rain falls. When people could finally see Titan close up, they were astonished at how much it resembles Earth. In 2007, the Cassini orbiter spotted something truly peculiar on Titan's surface. A land formation some 70 kilometers across, in the shape of a flower. What could it be? Perspective can be gained by combining images taken from two different points of view. A three-dimensional image of the topography emerges. That strange formation turns out to be a rugged mountain featuring a 1,500-meter high peak. There's also a chasm that looks like it might be a volcanic crater. From that, one can infer a formerly active volcano. That volcano has been an object of particular interest to Jonathan Lunine, an expert on Titan's internal structure. He says that the volcano did not spew lava. Rather, it pumped up a mixture of ammonia and water.
One thing to remember is that when water is mixed with ammonia, it can stay liquid down to very low temperatures, down in fact to -100 Celsius. But at that point, within a few degrees of that point, the liquid is actually very viscous. It's almost like basalt. And so if that is what is flowing out on the surface, we would see very thick flows.
Lunine believes that under the ice beneath the volcano, there's an ocean. He came to this conclusion due to changes in Titan's shape. Titan completes its elliptical orbit around Saturn once every 16 days. During that time, it regularly feels the changing effect of Saturn's gravity. In short, it experiences tidal forces. At its farthest point from Saturn, Titan is almost perfectly spherical. But at its closest point, where Saturn's gravitational pull is the strongest, Titan grows fatter. Its diameter alters by as much as 10 meters. Lunine says that Titan can transform so dramatically because internally it is not made entirely of solid rock. Lunin's observations suggest the following picture of Titan's structure. The outer crust of ice is some 50 to 100 kilometers thick. The center is comprised of two types of bedrock. In between the ice and the rock, however, is a layer of liquid water. The bedrock generates heat, says Lunin, permitting the water to remain in a liquid state. This ocean layer is some 300 kilometers deep. Ammonia, present in Titan since its origin, has also dissolved into the water. It is thanks to this ocean layer that Titan can change shape so flexibly.
The interior is warm enough that really only liquid water is a suitable, stable material in that region. So we're pretty sure from the gravity experiment that Titan has a liquid water layer under its surface.
According to Lunin, the tidal forces caused by Saturn in turn stimulate volcanic activity. Tidal forces cause friction along the boundary between the ice and the subsurface ocean. The water heated in this way melts some of the icy crust. It builds up like terrestrial magma and eventually forces its way up above the surface. This ammonia-laden water flows out from Titan's volcanoes like lava. Lunin believes such volcanoes are proof of an underground ocean. Beneath Titan's icy shell, a whole new world lies hidden. Saturn has over 60 moons. Among them are Enceladus, ice-covered like Titan, and Hyperion, pockmarked with craters. Mimas has this huge crater. Those are just a few of Saturn's moons, but they all have practically no atmosphere. Only Titan boasts an atmosphere that extends as far as 1,000 kilometers into space. Actual measurements reveal that this atmosphere is 98% nitrogen. The rest is largely methane. Why is Titan the only one of Saturn's moons with a thick atmosphere? Solving that mystery through experimentation on Earth has been a preoccupation of Yasuhito Sekine. Sekine believes that Titan's atmosphere was generated by an extraordinary mechanism. The mechanism? Collisions with small celestial objects. Sekine is trying to reproduce that effect using a laser. When Titan was first formed, its icy landmass contained about 1% ammonia. So inside a vacuum chamber, a disk of ammonia water ice stands in for the young Titan. The laser beam enters from the left of your screen. It strikes a projectile, which then impacts the ammonia disk. That was the laser shot. Gases released by the impact are measured. One is nitrogen, released by the disintegration of the ammonia. Titan's thick atmosphere contains large amounts of nitrogen. According to Sekine's calculations, based on his experiments, repeated impacts by small celestial objects could have produced just such an atmosphere.
タイタンの地殻中にもともと入っているぐらいのアンモニアの量があれば今の 1.5 気圧の窒素の大気を作ることができるということを、明らかにしました。重要な点はですね、大きい天体でないと大気を重力的に持てないということです。なので他の衛星たちは同じように衝突は起きたんですけど、それぞれが小さいがために窒素の大気を持つことができなかったと。
For example, Enceladus, one of Saturn's other moons, is merely 500 kilometers across. That is 1/10 of Titan's diameter. Saturn's other satellites are also small, with weak gravitational fields. So even if they've been similarly impacted, they haven't been able to hold on to any atmosphere. But did Titan in fact experience repeated bombardment by small celestial objects? Hal Levison uses computers to calculate the history of the solar system. He has advanced the revolutionary theory that some 4 billion years ago, the entire solar system was shaken by a massive event. Levison argues that when the solar system was forming 4.6 billion years ago, Uranus and Neptune were closer to the Sun than they are now. He inputs the location and size of the planets, and also of the small celestial objects that lie further out. Then the simulation begins. At first, the basic situation did not change much. But some 600 million years later, Uranus and Neptune were suddenly flung to the outer realms of the solar system.
Then out, okay? And that caused the giant planets to slowly spread. It was infinitesimal. You wouldn't have noticed it, but the orbits were slowly changing. And that continued until Jupiter and Saturn got to the point where Jupiter was going around the sun exactly twice. Every time Saturn went around once, and that configuration is what set the whole instability off. Okay, so you went almost overnight from a time when, okay, there was a little bit going on, but not much, to this very violent period where all hell breaks loose.
The smaller celestial objects, shown here in green, had formed a ring at the outer edge of the solar system. But then the gravitational force of Uranus and Neptune violently scattered these objects. The result was that in the period from 4 billion to 3.9 billion years ago, the planets of the solar system encountered a barrage of small celestial objects. During this period, Titan also was hit repeatedly, developing a nitrogen-rich atmosphere. That made it a very special moon.
たった1億年とかそれぐらいの短い期間なんですけど、その間にですね、その 1.5 気圧という膨大な量の大気を作ることができたというふうに考えられます。タイタンっていうのはですね、唯一人類が初めて見つけた生きている天体だというふうに言えると思います。で、地球と同じようにですね、表面で液体が存在して、それが蒸発して雲を作って雨を降らしてというような循環が起きているのはですね、現在の太陽系の中では地球とタイタンだけです。で、その点において40億年前のその出来事というのはタイタンにまさに命を吹き込んだと、生きている天体にしたという意味で非常に画期的な出来事であったというふうに思っています。
1977 saw the launch of Voyager 1. Its mission? To explore and observe the outer planets, from Jupiter to Neptune. This was its view of Titan. It was a close look, but still the moon was shrouded in a thick orange haze. However, even then, one scientist maintained that the haze held the secret to sparking life below. Bishun Kare has been trying to penetrate the mystery of Titan's haze since the early 1970s. he participated in the Voyager mission. He has focused on the haze as being itself a source of life. Carré introduces a nitrogen-methane mix into a sealed flask to simulate Titan's atmosphere. The flask is fitted with electrodes. Now Carré discharges them. This is meant to reproduce the effect of lightning or other energy surges on Titan's atmosphere. It's about 10 hours since the start of the experiment. A reddish-brown substance has become visible inside the flask. Carré claims that this is the very same substance as the haze enveloping Titan. So what happened inside that glass vessel? First off, the electrical surges split apart the molecules of nitrogen and the methane. Their atoms recombine with carbon and other atoms in all sorts of ways, forming a variety of new organic compounds. Analysis showed that some 200 types of organic compounds had been created in this experiment. Organic compounds are the materials out of which our own bodies are made. They are the building blocks of life. It was thanks to Carré's work that Titan came to be considered one of the celestial objects on which life might exist. The Cassini orbiter's close-up observations of Titan have come some 30 years after Carré's experiments. Will they confirm that Titan's hazy atmosphere has in fact given rise to organics? The INMS is a device that measures molecular mass. Cassini has used it to determine the composition of Titan's atmosphere. Cassini's data were streamed back to Earth, where they were analyzed by Hunter Waite and his colleagues. Waite led the team that designed the INMS instrument package carried aboard Cassini. Waite's lab was able to reproduce and confirm Cassini's data by utilizing the same INMS system. They could then analyze accurately whatever molecules or compounds the instrument had detected. The results were astonishing. Rendered in the form of a chart, each of the different molecules identified by Cassini is represented by its own colored area. Various organic substances were created in Titan's atmosphere, ranging from ones with a single carbon atom to more complex ones with 6 or 7 carbon atoms.
When Cassini sent back data, we found out that the upper atmosphere was much more relevant than we ever thought, that most of the chemistry seemed to be going on in the upper atmosphere, that very large molecules were being created in the upper atmosphere, way beyond our expectations. Titan is one of the best organic factories in the solar system.
Bathed in ultraviolet and cosmic rays, Titan's upper atmosphere is continually engaged in converting nitrogen and methane into a rich array of organic compounds. As these compounds collect in the lower atmosphere, they produce Titan's famous orange haze. Finally, they are precipitated with methane rain onto the surface as well. It's been 4 billion years since Titan's atmosphere was formed. During that time, it is estimated the organics settling onto the surface have created a layer dozens of meters thick. The dunes discovered near Titan's equator are thought to be a large deposit of these organics.
Now on Titan, the sand is made, we think, from organic material, and we think that material comes down and gets built up into sand-sized particles that are then accumulated by the wind to form dunes much like these.
Amidst this accumulation of organics on Titan's surface are substances of vital importance to the emergence of life. That finding was made by a young researcher with a specialty in organic chemistry, Sarah Hurst. Hurst has undertaken a minute examination of the organic compounds discovered in Titan's atmosphere. She's written her own computer program to do that. Based on Cassini's observational data, she faithfully simulates the composition of Titan's atmosphere and produces the same organics. Next, she uses her computer program to determine the molecular structure of every compound.
These peaks right here are the masses of the ions in the mass spectrum data, and then it's the number of carbon, nitrogen, oxygen, and hydrogen in each of those peaks. And so then what the code does is it goes through and compares this information to a list that I've given it of all of the amino acids and nucleobases that we're looking at. So here we have, at 136, we have the molecular formula of adenine, which is 5 carbons, that matches. It has 5 nitrogens, it matches. No oxygen, and then 5 hydrogens. So we know from this that we have the molecular formula of adenine in this sample.
Genetic information for all life on Earth is encoded in DNA. Adenine is one of its 4 major components, or nucleobases, and all 4 have been produced in Hurst's experiments. If these nucleobases combine in such a way that they create DNA, then a huge step forward will have been taken towards life itself. With this discovery, speculation mounted that Titan might actually be capable of harboring life. Life on Titan? It may in fact already exist. If it does, what would it look like? The search is on for the answer. Trinidad and Tobago form an island country in the southern Caribbean. They have a population of about 1.3 million. They also have one of the most unusual lakes in the world. It's called Pitch Lake. It contains not water, but naturally occurring asphalt. It bubbles up from an oil field that lies underneath, creating a lake of asphalt that's 40 hectares in area and 80 meters deep. Strangely enough, Pitch Lake is the site of fieldwork being done by astrobiologist Dirk Schultz-McCook. He thinks that Titan is the best candidate for the location of extraterrestrial life. He's come here to try to envision what life forms on Titan might be like. Asphalt, like methane, is a hydrocarbon comprised entirely of carbon and hydrogen. You wouldn't think this was a substance that harbors life, but Schultz-McCook says it actually does contain microorganisms.
Well, this is one of the few environments where it's similar to Saturn's moon Titan, where we know that we have hydrocarbon lakes on the surface. Obviously, Titan is very cold, so it's still different than from over here. but we do have their liquid methane and ethane, which are also hydrocarbons. And if we can find out what kind of organisms are living here in the asphalt lake and how they adapt to living in the hydrocarbons, we think we can get some ideas to how life could operate on a moon like Titan.
Asphalt contains almost no water.
Did you say that there's microbes in there?
Yes, there's microbial organisms in that liquid asphalt.
In this thing?
In this thing, yeah.
Like maybe 1, 2?
Millions.
Millions?
Yeah.
Genetic analysis identified some 600 new types of microorganisms living in the asphalt. Most are archaebacteria, related to the primordial microorganisms that live in extreme environments.
So for them, actually, it's a great environment, it's a great food source, and basically a never running out food source because it's getting supplied from deep down there.
On Earth, there are microorganisms that can use asphalt for sustenance instead of water. Schultz-McCook is convinced that in Titan's lakes, there must be life forms that exploit methane in a similar way. Another scientist, Chris McKay, holds that the methane lakes on Titan contain creatures so unlike Earth creatures that they exceed our wildest imaginations.
Think of fish living in water and ask them to imagine a bird which lives in air. They probably can't conceive of an organism that is so much denser than the medium in which it lives. Fish move through water by floating. So they would imagine a bird must float in the air.
We humans live in an environment called Earth. We produce energy by causing oxygen and organic matter to interact. That is our lifestyle. But McKay is arguing that on Titan, life forms would be based on a Titan lifestyle that makes use of what's available on Titan. Titan's atmosphere contains minuscule amounts of hydrogen and acetylene. McKay thinks that there may be life forms on Titan that exist by deriving energy from the interaction of those two substances in a methane environment. McKay says that life could very well already exist on Titan.
So instead of being small and round, I would guess that a single-celled organism on Titan might be big and flat, like a sheet of paper, to maximize its contact with the nutrients in this thin soup. So it's living in an environment where there's not a lot of food. So it's got to access the food with a big area. And maybe on this area, it has active molecules. So it's like a big flat sheet of paper with little traps on it to collect food. To that life form, that will be the normal environment.
It was not until the 21st century that Titan's thick veil was lifted. Now that we're getting a closer look, what new discoveries await?
So Titan gives us a whole new set of possibilities, and there are for sure perhaps hundreds, maybe millions of worlds like Titan around other stars. Do those have life? Titan maybe can give us some clues.
If life is found on Titan, humanity's view of the universe will surely change.
The best place for me in terms of finding another type of life would be Titan. Because if we find it on Titan, then we know that it really is too. It's not the same as us. When we go to Mars, we may find life on Mars, but we won't be sure that it's not the same life as Earth. So my best hope would be we find life on Titan, because then I know that we found two completely different types of life. Then I can go on to some other science problem.
There is only one body in space that we know of, other than Earth, that has a thick atmosphere and lakes. Titan. If life is found on Titan, it will instantly increase the possibility that life exists in many other places in the universe as well. We may not be alone in the universe. We may have many comrades. The quest to find out for sure continues. Clues to solving that great mystery lie hidden on Titan.
In 2004, the Cassini space probe approaches the ringed planet Saturn and its 56 moons. It discovers something almost unimaginable, conditions that might support life. And if those conditions could exist so close by, what might we find in the next galaxy? On a planet just like Earth. For millennia, we humans have looked to the skies and wondered whether we're alone in the universe. Today, we're closer than ever to knowing the answer. Some scientists believe we'll get our first look at our extraterrestrial cousins in the near future.
I hope it's in the next 10 years, and I'm ready for it next week. So, the sooner the better.
What's more, we could find these aliens not on distant planets in unexplored galaxies, but right next door in our own solar system. Scientists are now honing in on proof that ET is out there and living on the most hazardous of worlds. Our safari will journey to 7 destinations in our solar system to see just where these creatures could be and what they might look like. These exotic lands are unimaginably harsh. Life as we think of it would perish in an instant. But alien life may be far tougher than we expect, as we're learning from a surprising group of living things right here on Earth. Until just a few decades ago, we were sure our planet was unique. It is the only one we've found so far that has nurtured the evolution of millions of species. Thanks to its abundant sunshine, warm water, and protective atmosphere. We logically concluded that life needed each of those things, a conclusion that ruled out all other known worlds in our solar system. But then, biologists began combing some of the Earth's darkest and coldest places. And to their surprise, they found living, breathing creatures. Biologists call these organisms extremophiles. Some don't need light or oxygen. Others survive in tremendous atmospheric pressure. It seems life can turn up practically anywhere. Take Antarctica. After years of searching this arid, frozen landscape, scientists doubted they'd find anything alive. But in 1999, a team of explorers unearthed a rock from 6 feet under the ice. What they found amazed them. When they cracked the rock open, they found it teeming with tiny creatures. Here, at temperatures of 68 degrees below zero and 6 feet under solid ice, life had found a foothold.
Biologists have been increasingly discovering life, not kangaroos, but, simpler forms of life that live at very cold temperatures, very high temperatures, very great pressures, even in places where there's sort of a high degree of radiation. It turns out life is able to live in a much wider variety of environments on our own planet than we used to think.
And if life can survive extreme conditions, not just here at home, but elsewhere in our solar system, think of what this could mean.
Unless there's something extraordinarily miraculous about our solar system or our planet, then life has got to be extremely commonplace. I mean, there's got to be large numbers of worlds with life, and some of them would have cooked up intelligent life.
In the beginning, our Earth was as deadly a planet as any. Over the first billion years of Earth's existence, cosmic debris pummeled it mercilessly. The impacts turned its surface into a broiling, seething inferno where life was impossible. But once the solar system settled down and the Earth began to cool, water appeared, setting the stage for life. In 1953, researcher Stanley Miller proved in a lab experiment just how easily life on Earth got its start. He combined water with hydrogen, methane, and ammonia, components of the Earth's early atmosphere. Then he zapped his solution with an electric charge to simulate lightning. His results shocked the world. Miller had created organic molecules called amino acids, the protein building blocks of all living things. If lightning helped jumpstart life on Earth, could it have done the same on other planets? Galactic probes have now found the ingredients in Miller's experiment throughout our solar system, including one essential to life.
One of the requirements that every form of life that we know about on Earth has, every single one, is liquid water. We've used evidence for liquid water to kind of guide our search for habitable environments.
Our safari is headed to 7 worlds, some possibly rich in water, where scientists believe aliens might be hiding. While any life there might have begun much like life on Earth, how it looks now is anyone's guess. We begin in the world that has always fired our imaginations, the planet right next door, Mars. Of all the planets where we've looked for life, it's the one we've studied most. The scientist who may get the first look at Martians, if they're found, is Steve Squyres, principal investigator for NASA's Mars rovers.
Mars has always had, among all the planets, I think, a special fascination for humans. For a very long time, we've known enough about Mars to know that it is probably the most Earth-like.
It may be the most like Earth, with an atmosphere and seasons, but we humans would perish quickly on Mars. Its air is thin, 40 times thinner than the air at the top of Mount Everest. And it sits in a bad neighborhood of our solar system, near an asteroid belt. Its atmosphere is too flimsy to protect it. Asteroids continually bombard its surface. Violent winds can whip Mars's sandy soil into storms that consume the entire planet for weeks and spawn tornadoes 8 kilometers high. Midday temperatures at the equator of 1 degree Celsius fall to -70 at night. David Grinspoon is a curator of astrobiology at the Denver Museum of Nature and Science. As he sees it, Mars would be warmer if it wasn't a planetary runt.
When I grab coffee on a cold morning, I know that a small espresso is going to cool off quickly, whereas a larger coffee is going to stay warm much longer. Large objects stay warm longer because their interiors are shielded from the outside where the cooling occurs. And planets are exactly the same way. A small planet will cool off early in its history. A larger planet like Earth will stay warm for billions of years, which makes it a better place probably to look for life.
Despite Mars's drawbacks, it has always fascinated scientists because its terrain seemed to give evidence that it might support life. Its dynamic landscape of mountains, volcanoes, and deep ravines is not unlike our Earth. To early astronomers, these features look like oceans and rivers, and even a system of canals, supposedly not just supporting life, but actually produced by it.
Percival Lowell in the United States observed these things and inferred that, in fact, these things were so straight and so regular in geometry that they had to have been the product of intelligent life. Okay? Well, he was right. The problem was the life was at the wrong end of the telescope. In viewing this thing visually through a telescope eyepiece, the human eye-brain combination started to connect things that weren't really there.
Lowell was not alone. Some scientists were shocked when the probe Viking 1 beamed back this image. Is that a human face? Perhaps produced by Martians in their own likeness? Until recently, we've never really known where to look in our solar system for extraterrestrial life. But we've always known what the aliens would be like once we found them.
Consciousness. I was on a table.
Usually, there is more than a hint of the Earthling in our aliens. Hostile or lovable, they tend to resemble mutant images of ourselves. As a senior astronomer at the Search for Extraterrestrial Intelligence Institute in California, Seth Shostak has spent his career listening for the radio waves of a distant alien society.
There's no reason to assume that they're going to look like us or even think like us or behave like us or have language. You know, you just have to look at the variety of life on Earth and you see that, you know, nature can come up with lots of different forms.
But if there is life on Mars, how could it survive in such extreme conditions? Since the 1960s, scientists have sent dozens of probes to the Red Planet. The first pictures of the barren landscape quickly dashed any hope of finding intelligent beings. But what scientists did see startled them. Though there's no evidence of Martian-made canals, there are signs that Mars actually may have had water. Some think the angry red planet might once have been blue.
You just have to look back a couple of billion years, 3.5 billion, 4 billion years ago. Mars had a thicker atmosphere, had water on its surface clearly. Maybe it developed life. And as it slowly went bad, you know, the life had to adapt.
Life may have adapted, not died off, because some liquid water may still exist underground. But with no surface water, frigid temperatures, and ultra-thin atmosphere, Mars is a planet only one kind of creature could love, an extremophile. Extremophiles thrive in the cruelest of places. To see where they might lurk on Mars, we head to the Valles Marineris, a massive rift in Mars's surface, 20 times wider than the Grand Canyon in places, and almost as deep as Mount Everest is tall. Lakes may have once flooded this valley, and those lakes could have hosted life. As the water dried up, life could have evolved to cope with the harsher environment. We won't know what these extremophiles are like until we find them. But they may resemble creatures that exist in extreme places right here on Earth. An unusual team of biologists, called astrobiologists, study Earth for the kinds of life we may find in outer space. Astrobiologist Rocco Mancinelli is on the hunt for Mars's extremophiles.
If it went beneath the surface, and some of it undoubtedly did, then what happened to it? Well, it formed brine pockets. So what kind of organism can live in a salty brine? A salt-loving organism.
Astrobiologist Chris McKay thinks he knows the kind of salt-loving creatures that might survive on Mars. Creatures much like those he's found in one of the driest, saltiest places on Earth.
The fundamental challenge to life on Mars is, in a sense, the fundamental challenge of life here in Death Valley. It's dryness. That is the hardest thing for life to adapt to.
Thousands of years ago, a salty lake covered Death Valley, just as lakes filled Mars's Mariner Trench.
We move in closer. This is still wet, a little wet. This appears like a lifeless place, a big, flat, white, empty horizon. But yet, just below the surface, we find layers of algae and bacteria growing. They're living in an environment that in many ways is fundamentally different from the environment that we sense on the surface. Here you're in a place which looks lifeless, looks dead, and yet you dig down and hidden underneath, there it is.
Beneath the salt is a layer of hardy green algae that survive on the water and light that trickle through. The algae in turn feeds salt-loving microorganisms.
Here in deserts on Earth, dried, salty lake beds, we're going to find them on Mars as well.
Salty deserts are not the only places life might be hiding on the red planet. There are Mars's tremendous volcanoes, some of them 6 times larger than those on Earth. Astrobiologist Penny Boston studies the caves, called lava tubes, left over after volcanic lava has dissipated. Not long ago, we assumed caves like these were devoid of life. They get no sunlight, and no sunlight means no photosynthesis. But in lava tubes outside Albuquerque, New Mexico, Boston has found evidence of extreme life.
Because we know Mars has many, many lava tubes. And so here we have the opportunity to see how these formed and also to look at the life that inhabits them.
The extremophiles Boston has found appear to be thriving. They get their energy by feeding on the minerals in the cave wall.
So here we're up close to the wall, and you can see these white patches here growing against the black basalt. And each one of these is like a major city for these little guys. They're all nestled in these little pockets in the basalt. And so these guys are permanently adapted to these freezing temperatures. They never see any light, and they get what they can find in the environment.
Are there creatures like these in the caves below Mars's volcano fields? Boston thinks so.
We are going to find life, and I just hope that I live a long and healthy life so that I can still be around to see that.
We may already have had our first glimpse of Martians, not from our visit to their planet, but from their visit to ours. 16 million years ago, an asteroid slammed into Mars and propelled a 2-kilogram rock into space. Amazingly, that rock sailed to Earth and came to rest in Antarctica. Inside, NASA scientist David McKay and Everett Gibson were amazed to spot the outlines of fossils. Water has carved small tunnels in the rock. And in these tunnels, McKay and Gibson found what they believed to be evidence of bacterial life.
These are little microbes, and they're dead, and they're fossils, or in some cases, We don't even see the forms. We see the footprints or the evidence that they were there.
Life from Mars? Maybe. The hunt is only just beginning. NASA plans to send a rover called Phoenix to Mars. It will study the planet's ice cap and probe 3 feet beneath the surface. NASA even has a plan to send human visitors. They may not meet the little green men of our imaginations, but they could encounter life in some form. What will it look like? It is likely to be a subterranean dweller with an ability to survive on little water. Perhaps an organism with a taste for minerals, like the creatures in the lava tubes of New Mexico. Even the smallest find would have enormous implications. Proof that life is not unique to Earth, but exists just next door. Our safari to the places in our solar system likely to harbor alien life now takes us past the asteroid belt on the far side of Mars. Here, Jupiter reigns. But this planet, the largest in our solar system, is fairly hostile to life, thanks to its toxic gases and overpowering gravity.
Not only is it pretty cold out at Jupiter, it's also, it's got this really thick atmosphere, tens of thousands of miles thick, and it's got ammonia and methane and, things used to clean the bathroom. But Jupiter has more than 60 moons that we know about.
At first glance, those moons would seem unlikely places to seek alien life. Their atmospheres are thin, and they are inhumanly cold. The temperature on Callisto is lower than -200 degrees Celsius. The scientific probes Voyager and Galileo have detected little on the surface of these moons but ice, with one dramatic exception. Io is one of the closest moons to Jupiter. When NASA sent Voyager 1 to Io in 1979, astronomers were astonished to find its surface roiling with giant volcanoes.
Io is the most volcanically active place in the solar system, just spewing volcanic material from its surface all the time.
What could be heating the interior of this frigid moon? Amazingly, it's the force of gravity from Jupiter. The giant planet exerts enormous gravitational pull on its moons. The closer the moon, the stronger the force. So strong, it can actually stretch their crusts. But some of these moons have elliptical orbits, so as they near Jupiter, the crust stretches towards it. When they move further away, the crust relaxes back towards spherical. This constant tidal movement creates friction deep inside, and that friction generates heat. It's like rubbing 2 sticks together to start a fire. The pull of Jupiter is heating Io from the inside out. Volcanic fumes and lack of water make Io inhospitable to life. But Jupiter's other large moons are more distant, close enough for Jupiter's gravity to warm them from within, but distant enough to remain calm on the surface. 3 of them look particularly promising as possible homes for alien life. The one furthest from the giant planet, Callisto. On its surface, Callisto looks like our moon, scarred and cratered by countless hits from asteroids. Those impacts may have melted the surface ice for brief periods, allowing life to take hold. But in 1998, the Galileo spacecraft detected a much more promising incubator deep beneath Callisto's surface. Radioactive rocks and tremendous pressure in its core generate heat inside Callisto. The heat may be melting its icy crust from below, creating a hidden ocean. And hidden oceans could mean hidden life. As we fly closer to Jupiter, we find its largest moon, Ganymede. Ganymede is also deeply scarred. Ridges rise above its surface. Those bright spots are craters as big as 5 kilometers across and likely to be lined with frost. But these photos offer the most compelling clues to where life here might hide. They show flowing glaciers, glaciers that resemble those on Earth. Ganymede's moving glaciers could also be signs of heat within. So, like Callisto, Ganymede could also have a hidden ocean, buried beneath as much as 190 kilometers of ice. The third moon on this leg of our alien safari is the most intriguing. It is called Europa, and of the three, it resides closest to Jupiter. That proximity to the giant planet means Europa's core may be very hot, far hotter than Callisto's or Ganymede's. But its surface remains frigid, a potent combination for life, since there could be a temperate zone where they meet. Mammoth fissures scar Europa's thick crust of ice, a sign that ice is always shifting. On our own planet, we see the same cracks in the ice sheets covering the Arctic Ocean. Europa's crust may be riding the largest ocean in the solar system, an ocean twice as large as all of Earth's put together.
Now those oceans, if they're there, and the chances are pretty good that at least some of them are, they've been sitting around for a long time, 4 billion years, a little longer, right? In 4 billion years, an ocean of water, do you think anything might have cooked up there? Well, it certainly seems plausible.
The environment in Europa's ocean is more or less as nice as the environment in our own ocean, as a place for living things to exist. Heck, things from planet Earth could probably live in the European Ocean.
But Europa's oceans would be very cold, even slushy. And sunlight never penetrates them, thanks to an icy cover that may be 16 kilometers thick. We might never have thought life could exist here, if not for a revolutionary discovery off the coast of Ecuador. Deep in the Pacific, biologists have found flourishing communities of tube worms, crabs, and even squid. These creatures are thriving despite complete darkness, extreme cold, and the pressure of the deep ocean. They feed on bacteria that take their energy not from the sun, but from chemicals erupting from the sea floor. We might find very similar volcanic vents on Europa, supporting their own web of life. To find out, NASA scientists would like to put a lander on the European surface. Some would like to send a cryobot, a robot that would melt the ice and release a probe into the liquid below.
That's not so hard to do. You just have to melt your way through. But you're going to have to melt your way through not a couple hundred feet, but maybe a dozen miles of ice. And send down a fishing line with maybe a video camera and a light bulb on it and look around.
In all that water, we can't rule out the possibility that very simple life forms have evolved further. We might even find creatures as advanced as some here at home. Most likely, however, we would find microbes. But even that would be a sea change in how we view the birth and growth of life. Europa was warm. What if the place is one of the coldest known? Or if its lakes flow with toxic chemicals instead of water? These are the worlds we find as our safari continues, even deeper into space. As our safari in search of alien life sweeps by the ringed planet Saturn, we can see the violently swirling gases that choke its atmosphere. We can also feel Saturn's gravity, weaker than Jupiter's, but still formidable. We'll keep moving. We're not likely to find living things here. Saturn's rings are also extremely inhospitable. They're made of rock and ice, as small as a grain of sugar or as big as a house. But Saturn has many moons, 56 that we've spotted so far. Our safari heads first to one of those moons, a tiny frigid satellite called Enceladus, just 500 kilometers in diameter. Here, gravity is very weak, a fraction of that on Earth. And Enceladus has hardly any atmosphere. It reflects back into space almost all the sunlight that hits it, making it the shiniest object in our solar system. Until very recently, we also thought Enceladus was too cold to support life. It appears we were wrong. In 2005, after a 7-year journey, the Cassini spacecraft approached the tiny moon and detected something that stunned the mission's principal investigator, Caroline Porco.
So this was the picture that just, grabbed us. Just was shocking.
Those are plumes made of water from a geyser. The geyser's steam and hot water hit the cold vacuum of space and explode into a jet of ice. With little gravity to rein it in, the ice cloud can grow as big as Enceladus itself. Porco has never seen anything like it anywhere else.
It's like a planetary explorer's dream to come upon a body like Enceladus. Those jets, those fountains, if you will, just spewing vapor and icy snow hundreds of kilometers above the south pole of Enceladus.
There's only one conclusion. Tiny, frigid Enceladus is piping hot within. Like Jupiter, Saturn's giant gravitational field tugs on its satellites, creating friction and heat within.
As far as we can tell now, it seems like an inescapable conclusion that there may be liquid water deeper down on Enceladus because it's warm. And the best models we can put forth right now to even explain the warmth, much less the jets, seem to indicate that you would get temperatures warm enough to melt water.
Heat, liquid water, even the furthest reaches of our solar system may contain the chemistry for life. What kind of creature could live in the steamy waters of a geyser? Thanks to hot springs back on Earth, we have some idea. At one point, we assumed nothing lived in the steam-driven fountains of Yellowstone National Park. But then, biologists discovered microbes in these waters. Microbes that feed on chemicals dissolved in the water. Today, we call them thermophiles. The hardiest can thrive in boiling water. Could there be thermophiles on Enceladus? To find out, our safari takes us in for a close-up of this extraterrestrial Old Faithful. It's too cold for anything to live near the surface, but temperatures there are minus 165 degrees Celsius. But what about the hot water inside? In the ice plume above Enceladus, Cassini's probes have found carbon dioxide and methane, chemicals that could feed life below. Just as the chemical-laden springs of Yellowstone feed microbes living there.
We have a body that very, very likely has liquid water in its interior, has shown us already it's got simple organic compounds and, a whole host of things that make it, I think, a major body of astrobiological interest in our solar system.
If Enceladus has been a shock, astronomers have been astounded by another of Saturn's moons, Titan. It may be the unlikeliest to harbor life. Titan gets only a limited amount of sunlight, about 1,000th as much as Earth. Probes sent to Titan have detected ice, but no liquid water. And at temperatures of minus 138 degrees Celsius, that ice is hard as stone. What could possibly make Titan a promising environment for alien life? Remarkably, Titan in many ways resembles the Earth, but not the one we know now.
Titan has turned out to be the body fantastic in the Saturn system, which is long suspected of having an environment at the surface, not only similar to the kind of environment we find here on Earth, even, believe it or not, similar to the kind of environment we had on Earth before the emergence of life.
Titan intrigued Carolyn and Porco's team so much, they directed the Cassini spacecraft to send a probe there in 2005. It was the most distant surface mission ever conducted. The probe saw just ridges and plains. But a later flyover by Cassini spotted a shoreline. Soon, thousands of lakes came into view, at least one bigger than the Great Lakes of North America. It's the first time we've ever detected liquid on the surface of another celestial body.
Kind of looks like Minnesota, except the lakes are not water. They're liquid natural gas. But liquid natural gas is a liquid.
And that's not snow. Those are methane flakes. Like Earth, Titan has weather, but it's of a rather psychedelic kind. There are even methane hurricanes.
It's not water, it's methane, doing all the exact same things. Raining, evaporating, flowing in rivers. So you have something that is basically doing what water does on Earth, on Titan, only it's methane.
A similar scene may have existed on Earth 4 billion years ago, making scientists suspect that Titan could also be an incubator for life.
Chemistry does go on. At those cold temperatures, it's really slow. But Titan has had 4 billion years in which to do some chemistry, and maybe in that period of time, maybe something is cooked up.
It would have to cook up without liquid water, something we've never seen before. But scientists aren't ruling it out. The substitute could be the methane, so abundant on Titan. Used for fuel on Earth, methane was long thought poisonous to all life. But in 1997, researchers examined mounds of methane ice in the Gulf of Mexico, and they were astonished to find colonies of small centipede-like worms thriving amid the frozen substance. They think the worms may eat bacteria that feed on the methane.
In general, things that we think of as deadly, many of them are potentially lively. If you can figure out an evolutionary way to tap into that energy rather than having it destroy you, then it can be bountiful.
There could be one more complication for life on the surface of Titan. With only a weak magnetic field to shield it, living things on the surface could be exposed to cosmic radiation. But that might not be a problem for an extremophile, as we found here on Earth. Biologists have uncovered plenty of life near Chernobyl's contaminated nuclear reactor, and even swimming in toxic radioactive spills, actually feeding off the decaying molecules. It's possible Titan's life forms could do the same. To find life on Titan, we may have to dive into its methane lakes, where we might find chemical-loving bacteria. We may even find microbes resistant to radiation, not unlike those here on Earth at Chernobyl, living on its rock-hard ice sheets. Organisms that eat methane might give off heat, melting the ice, possibly creating another fountain for life. There's no doubt, life on Titan would be a strange brew. But we have yet to visit the most bizarre world where scientists believe life could exist. And it's much closer to home. Our safari of the world's most likely to harbor alien life has taken us far. We've visited frigid deserts, submerged oceans, and methane lakes. But the world we are about to visit may be the most extreme of all. For our final stop, we are turning back toward Earth, to Venus, our closest planetary neighbor in the solar system. If life can survive here, it seems it could exist almost everywhere. To reach the surface of Venus, we have to fly through a dense layer of yellow clouds, 64 kilometers deep, with a composition similar to battery acid. The atmosphere here is 90 times heavier than Earth's, too heavy for a human to tolerate. On the ground, there are extinct volcanoes and lava flows as far as the eye can see. They cover 85% of the planet's surface. It is hard to believe Venus once had vast oceans.
You basically had a runaway greenhouse effect, where as it starts to get warmer, the oceans start to evaporate, and then that puts water vapor in the air. Well, water vapor is a potent greenhouse gas, so that's what leads to the runaway. The oceans basically boil off, and then the CO2 all ends up in the atmosphere, and so today you have this very hot, hyper greenhouse planet.
With temperatures around 460 degrees Celsius, Venus is even hotter than Mercury, the planet closest to the Sun. Not a surface hospitable to life.
Life, as we know it, cannot exist on the surface of Venus because organic molecules would just be ripped to shreds by the hot gases.
But we've stopped here, not because of what's on the ground, but what's in the air. In 1982, the Soviet spacecraft Venera 14 visited Venus. In the clouds, 50 kilometers up, it detected temperatures much cooler than on the surface. What's more, it found the molecules so critical for life, H2O. So far, every bit of water we've found beyond Earth is frozen solid. Only in the clouds above Venus have we found it in vapor form, a possible incubator for life. But Venus's clouds are also filled with highly acidic sulfur. Once, we thought nothing could live in sulfur. But scientists have analyzed some of the most acidic water on Earth, leaching from a California mine.
Watch your head, sulfuric acid.
In sulfuric acid strong enough to erode metal, eat through clothing, and dissolve human flesh, they found life. Acid-loving extremophiles. These organisms feed on sulfur compounds, like iron sulfide, eating the iron and emitting the highly acidic sulfur. Do extremophiles like these float above Venus? Astrobiologist David Grinspoon likes to think it's possible.
Maybe in the clouds of Venus there are some sulfur-based organisms. Sulfur actually absorbs ultraviolet light in interesting ways, and I'm just imagining that there's maybe some kind of photochemical reaction going on where ultraviolet light is actually being used to convert chemicals into some higher energy state, which then is basically being eaten.
What will these aliens be like if we do find them? They would have to tolerate high temperatures and enormous atmospheric pressure. They would also need to thrive in acid concentrations deadly to most life forms. Perhaps they might resemble a hardier version of the acid-resistant extremophiles in California's mine.
We keep finding that life lives in places that we used to think were inhospitable. So whenever we say, oh, it's impossible, you couldn't have life in the clouds of Venus, I think we have to be very careful because they might just reflect our own ignorance or our limitations on our own imagination, and maybe not real limitations on the ultimate creativity of nature, which
safari returns to the cool, blue, lush and lively world of Earth, we can see why we so revere its life-sustaining gifts. But, as we are learning, even the most extreme environments can harbour living things. Extremophiles may resemble the first version of life in our universe. They can even be the most common. Could they have evolved further from these humble beginnings? Could intelligent life be out there as well? For more than 40 years, scientists at the Search for Extraterrestrial Intelligence Institute in California have been searching the skies for answers to that question. Astronomer Seth Shostak believes he'll know the sound of alien life when he hears it.
We have a couple of observing projects to try and find signals. The biggest one are our radio searches, and that's where we use big arrays of antennas, and we point these antennas at nearby star systems that we think, well, this is the kind of star that might have a planet that might be something like Earth. We point in those directions, hoping to pick up a signal that would tell us that somebody there is clever enough to build a radio transmitter.
It's a safari that never leaves home. Astronomers have also recently captured enough light from planets in distant solar systems to deduce their chemical makeup. They have found elements that may help form RNA, one of the building blocks of life here on Earth. And 20 light-years away, in the constellation Libra, a team of European astronomers has found a planet that could be warm enough to have liquid water on its surface, just like Earth. Meanwhile, headed to the furthest reaches of our galaxy are 4 spacecraft launched in the 1970s. Aboard 2 of them is a map of our solar system and the image of a man and a woman. 2 others carry a sample of uranium, whose rate of decay would date the probe, regardless of language. The 2 are also carrying what could be the most universal message of all, a recording that includes a composition by Bach. Just don't expect news anytime soon. These intergalactic postcards from the Earth will take 80,000 years to reach the nearest star. Our search for life beyond Earth has only just begun. There are billions of planets yet to be explored. Every one of them holds the tantalizing possibility of life. Even intelligent life.
Just in the face of this enormity, the idea that we're the only game in town, it just doesn't seem reasonable.
I think the question of whether we're alone is profoundly important for human beings in general. If you're aware, you really have to ask that question.
Somewhere in a galaxy known or unknown, something or someone could be looking out into space, peering at the Milky Way and wondering, is there life out there?
Some with moons. Their names may be unfamiliar. Eris, Makemake, Haumea. But they hold clues to all our origins. And the first of these worlds, and the one we'll reach in 2015, is the king of the Kuiper Belt, Pluto. The long journey of NASA's New Horizons mission began in 2006 aboard America's biggest, baddest rocket, tricked out with every conceivable booster.
We built a very light spacecraft and bought a very large launch vehicle, and the combination is ferocious.
But in some sense, it all began in 1930 with Clyde Tombaugh, 24 years old and fresh off a farm in Kansas, but willing to spend long hours scanning star fields to find a moving point of light. Humanity's first glimpse of Pluto. The dream of actually getting to Pluto began with a 6-year-old boy in love with science who grew up to lead a team of brilliant researchers and engineers with dogged persistence through decades of planning and building and testing. A race against time just to get to the launch pad.
Exploring the outer solar system, because it's so far, takes a lot of time. It requires a lot of patience, a lot of dedication, a lot of perseverance. But it's the frontier.
Assuming all goes well at Pluto, NASA may choose to extend the adventure further out into the Kuiper Belt, the solar system's mysterious third zone.
This is maybe the one chance in my lifetime that we're going to get a spacecraft out there and look up close at one of these Kuiper Belt objects.
December 6th, 2014.
We are now to wake up with the New Horizons spacecraft.
New Horizons wakes up for the last time from hibernation.
New Horizons is speeding towards Pluto at a phenomenal rate, and we can't wait for it to get there.
January 27, 2015, 6 months of approach science begins. July 14, 2015, New Horizons' long journey, 3 billion miles, 9 years in flight, and 85 years of speculation about Pluto, climaxes in one day of close approach and flyby.
You know, we're rounding third base and we're headed home.
The dream, the adventure, the promise of discovery. That's what makes 2015 the year of Pluto. Studying Pluto and its neighbors from Earth is one of the toughest challenges in astronomy. It takes the largest telescopes and most advanced instrumentation on the planet. And it's tough even for the Hubble Space Telescope. And it takes time, from the discovery of Pluto in 1930 to NASA approving the New Horizons mission in 2001 to arriving at the planet in 2015. It's been 85 years, and time passing is definitely an actor in our story. But it's the combination of human skill, cutting-edge image processing, and sheer bloody-minded persistence that has resulted in the most important discoveries. And that's a tale as true today as back in 1930, when Pluto was first found by Clyde Tombaugh. In 2011, at the SETI Institute near San Francisco, Mark Showalter used Hubble data to discover 2 new moons around Pluto, although he was actually looking for possible rings. Showalter has found rings associated with small moons around other planets.
And that was kind of the motivation for checking out Pluto. It's got 2 little satellites. Satellites raise clouds of dust. Let's see what might be there.
It's easy to take artistic license to show what Pluto's rings might look like. In reality, it's incredibly hard to see faint objects against the dense background star field and the glare from Pluto and its large moon, Charon.
We came up with this trick where you take the images and then you rotate the camera 90 degrees, you take more images, and if you do that all just right, you can do this thing where all that glare cancels out, and what we're left with is just the rings. We could think of it as a stack of images. Think of it as like a cube looking down. So let's turn it on its side. So now if we start peeling off the layers and looking downward through the stack, things suddenly become much, much cleaner. For example, Hydra and Nix show up very, very cleanly. But the thing that immediately caught my eye was this little dot right there. It's not a perfectly sharp hot pixel like over here, and that's what made it pretty convincing to me that we had seen a very small moon of Pluto that nobody had seen before.
To be sure you've detected a real moon or planet, you have to show it's moving, unlike the background stars.
The thing that makes moons distinctive is if we come back later, they'd all have shifted because they all orbit the central planet. This required a great deal of patience to then wait about 6 days until we got our next set of observations of the Pluto system. Sure enough, the object was still there. It had moved by just about the right amount to be something orbiting Pluto, and we knew we had a moon.
Next year, Showalter and colleagues went back and built on lessons learned to see what else might be there. Summer 2012. Now, Mark had 15 more days of Hubble observations.
Now, what you can see here are 3 time steps. Each of those time steps is actually about 45 minutes of data. That means it's long enough that the little moons move. It's moving back and forth in this 3-frame sequence. Hydra is moving, Nix is moving. I mean, it doesn't take a rocket scientist to say that that looks like a little moon of Pluto. It's moving just the way the others are. They're all going around the planet in the same direction. And so it was just a couple of weeks later that we made the announcement that the fifth moon had been discovered.
Patience, persistence, ingenuity. That was exactly what led to the discovery of Pluto back in 1930. In Kansas in the 1920s, Clyde Tombaugh grew up in hard times and built telescopes using leftover farm implements. To check the accuracy of his best telescope, he sent drawings of Mars and Jupiter to the Lowell Observatory in Flagstaff, Arizona. They were looking for staff, and he was hired. Along with observing the stars, he stoked the furnace and shoveled snow. But one assignment made history. Day after day, he'd use this machine, known as a blink comparator, to look for anything in his images that moved. It was tedious, painstaking work, but on plates taken on January 23rd and 29th and analyzed in February, he saw a small dot that did move against the fixed stars. Announcing the results after careful confirmation, the observatory made it easy to find the new planet by adding arrows.
This is an incredible work of observational astronomy, and having done something similar but with much more powerful tools, I can really appreciate his achievement.
For decades, Pluto remained, more or less, a point of light. But in the mid-70s, Dale Cruikshank and colleagues attached cameras with infrared filters to a telescope at Kitt Peak.
Detectors or sensors had been improved, and larger telescopes had become available. Well, we did that work in 1976 and found evidence for frozen methane on Pluto's surface. It was several years later that we found the evidence for the other ices.
In 1978, astronomers Jim Christie and Bob Harrington analyzed new plates taken at the U.S. Naval Observatory in Flagstaff. Christie noted an elongation to the north of Pluto. 1 month later, the bump had disappeared. From this and other evidence, they concluded that Pluto, like Earth, had a moon, Charon. From eclipses between Pluto and Charon occurring in the 1980s, astronomers calculated that the moon was almost half the size of its parent body, so large that both objects spin around their mutual center of gravity, outside Pluto. Pluto and Charon were the first double dwarf planet combo discovered in our solar system. Using the basic physics of their orbits and the distance between them, astronomers could calculate their mass and size. Pluto was a little smaller than Earth's moon, about 1,500 miles in diameter, and had only 1/10 its mass. Between 1985 and 1990, astronomers were in luck. As Pluto and Charon orbited their mutual center of gravity, each passed in turn in front of the other. The so-called mutual events allowed astronomers like Mark Bowie to capture the changing patterns of light. Patiently, Bowie created a map of Pluto. Pluto turned out to have one of the two most contrasty surfaces in the entire solar system. In the mid-90s, Bowie and Alan Stern used the Hubble Space Telescope to make the first direct images of Pluto's surface.
And it's exciting to Mark and I and to our whole scientific team to be able to see this object that no humans really could glimpse as a real planet, as a real object in the solar system previously.
In 2005, Hal Weaver and Alan Stern used the Hubble for another close-up look at Pluto and Charon. They discovered two small, dim moons where only Charon had been seen before. Now we know from Mark Showalter's work that there are two more moons, making the current total of 5, and that Pluto is a genuine many-planetary system. From its size and orbit, astronomers estimated that Pluto is perhaps 70% rock and 30% ice. That makes it one of the largest of a whole new class of objects, the ice dwarf planets, making up what's known as the Kuiper Belt. This region is named for Gerhard Kuiper, a leading mid-20th century planetary astronomer. Kuiper suggested that the solar system didn't end with Neptune and Pluto, but that there should be a disk of other worlds beyond them. In 1992, from a mountaintop in Hawaii, David Jewett and Jane Liu found the first Kuiper Belt object. They were using new and highly sensitive CCDs, like the sensors in a modern digital camera. But their technique was essentially an updated version of Tombaugh's work. take carefully registered images of a patch of sky and see if anything moves against the distant stars. This one, QB1, did just that. It was only a few hundred kilometers across, 10 times smaller than Pluto, but still huge compared to a comet. Since then, teams of astronomers have found around 2,000 KBOs. Informed by cutting-edge astronomy, but with a fair dose of artistic license, let's take a trip through this third zone of our solar system.
We used to think of the solar system consisting of two different types of planets. The planets we call the terrestrial planets, which are Earth-like planets. That would be Mercury, Venus, Earth, and Mars.
Next out, the asteroid belt. Fragments of worlds smashed to pieces by gravitation and collisions. Then come the four gas giants. Jupiter and its moons. Saturn with its magnificent rings. Uranus, also ringed. And Neptune.
And then Pluto was this kind of, odd guy out. It was this little object at the edge of the solar system. And then when we found all these other Kuiper Belt objects, this is kind of almost a third type of object.
So for the first time ever, we'll be able to fly by a brand new object, an object that's been forming for billions of years, and understand what outer parts of the solar system are all about.
By July 2015, we'll know for sure what Pluto and its moons look like, and that will provide breakthrough information on all those other ice dwarf planets, the most numerous planetary objects in the entire solar system that make up the Kuiper Belt. Actually, the Kuiper Belt is more like a donut, bulging up above and down below the ecliptic where most of the planets move.
It's kind of like the asteroid belt, but much bigger. It has hundreds of times more objects in it than the asteroid belt.
Let's now visit 5 named KBOs in the exact positions they'll be in on July 14th, 2015, the day when New Horizons flies by Pluto. Quaoa was one of the first Kuiper Belt objects discovered. It's about 1,000 kilometers in diameter, a reddish world, covered in water ice, methane, and ethane. And like many KBOs, it has a tiny moon of its own, Wayuut. Up above and down below the plane of the solar system, numerous KBOs have been flung about by Neptune's gravity. This region is known as the scattered disk. One of the largest of these KBOs, Eris, is close in size to Pluto and is made of rock and methane ice. Astronomers categorize KBOs by the tilt of their orbits relative to the plane of the solar system. And one of the more highly inclined orbits belongs to Makemake, named for a Hawaiian creation deity.
Some of these have methane or water ice on their surfaces. Some of them just seem to be covered in some brownish gunk. There are gray objects out there. There are brown objects out there. There seem to be distinct populations.
Some of them seem to be very spherical, and so they probably have warm interiors, and then others are peculiar shapes which suggest they're very cold and strong.
Perhaps the most bizarre and unexpected KBO is Haumea, a KBO shaped like an American football, made of rock and ice. It's white with red splotches and orbited by at least 2 moons. One of the strangest orbits of any KBO belongs to Sedna, discovered in 2003. Its orbit is the most eccentric of any KBO now known, bringing it as close as 76 AU to the Sun, but then carrying it outward to 936 times the Earth-Sun distance. Sedna's strange 11,000-year orbit seems to link it to an even vaster cloud of objects, ready for exploration by future generations. The Oort cloud is an immense icebox of long-period comets, from 10 to 100 times more distant than the Kuiper Belt, surrounding all the known worlds of our solar system.
There's a real record of the early history of the solar system out there in cold storage at the edge of the solar system.
This is what was left over. Pluto is the first member of that group.
But to begin humanity's exploration of the Kuiper Belt, you first have to get to Pluto. And that means getting a mission approved, a spacecraft designed and built, and delivered to the launch pad on time. And none of that was easy. 2015 may be the year of Pluto, but getting there has taken many long years of effort. And for New Horizons, there's a date when things got started: 1989. It was the year when George Herbert Walker Bush became president and the Berlin Wall fell. Far from Earth, it was also the year when NASA's Voyager spacecraft flew by Neptune and returned the first images of its moon, Triton. Hairstyles of some New Horizons scientists were very different, but for them, May 5th, 1989 was a most important date.
That's the day that I marched into the then Division Director for Planetary Science at NASA headquarters, Jeff Briggs, as a graduate student, and asked him why we aren't studying the mission to Pluto. And he responded, because no one's ever asked me before. That seems like a brilliant idea. Why don't we do that?
Space missions rely on hundreds, if not thousands of people, but sometimes it takes someone with passion and persistence to make things happen. And for New Horizons, that's Alan Stern.
I was interested in this when I was a boy, so I've been somewhere between in the groove and stuck in a rut for 40 years.
There'd been some thought about sending one of the twin Voyager spacecraft past Pluto to complete the exploration of the known solar system. But in the 70s, the scientific establishment wasn't convinced Pluto was all that interesting. Young grad students like Alan, Mark Bowie, and Fran Bagenal thought differently.
Back in, about late 1989 or so, there was a bunch of us who were really keen to go to Pluto.
And the thing that drew me to it the most was the fact that we knew so little. Here's the frontier.
So it was a bit of an opportunity for young people to come in and say, hey, where are we going to go next? What's the next great frontier that we should go explore? And it was clear, out to the Kuiper Belt.
Alan, Fran, Mark, and a small band of enthusiasts became known as the Pluto Underground.
So we realized to make this happen, we had to get together and campaign hard to make the case to go there and explore this little planet with all its moons.
All through the 90s, there were many competing plans for a Pluto mission, like the Pluto Fast Flyby, the Pluto Kuiper Express. A Pluto mission was on, then off, then on, then off.
If the Pluto mission had been a cat, it would have been dead long ago because they only get 9 lives. And we've had significantly more than 9 stoppages and odd twists and turns.
What finally turned the tide was the National Academy's Decadal Survey, a consensus document from leading planetary scientists that ranked a Kuiper Belt Pluto mission highest in priority for medium-class budgets. Finally, after competitive proposals were evaluated, New Horizons, which teamed Alan Stern with the Johns Hopkins Applied Physics Laboratory, APL, and several other institutions across the country, was selected by NASA on November 29, 2001. Now, plans on paper became metal in clean rooms. In 2004, lead scientist Alan Stern described the mission's key science objective.
Well, you know, the key to planetary science is that you really have to go places to get the resolution, to get up close enough to really see what's going on. We want to get up close and personal.
The very best resolution of current telescopes looking at Pluto would give this kind of fuzzy image of a much more familiar world. But here's what New Horizons would see if flying over New York City. Lakes in Central Park, wharves on the Hudson River.
New Horizons is the first really of a whole new breed of spacecraft that is focusing on a very specific task.
For this first mission to Pluto, the questions are basic. What do Pluto and Charon look like? What are they made of? How do their atmospheres behave?
We had to really be disciplined and say, we can't do everything. Let's focus on the primary questions and design the instruments to answer those primary questions.
The long-range imager, LORRI, will be used for navigation approaching Pluto and close-up views during the flyby. The wide-angle camera, RALPH, has both visible light and infrared sensors to map Pluto and Charon and characterize their icy surfaces. There are 2 fields and particles detectors to probe the solar wind at Pluto. The large radio antenna is an essential communications device, but both REX and ALICE, an ultraviolet imaging spectrometer, are part of experiments to analyze Pluto's atmosphere. And there's the Venetia Burney Student Dust Counter, built by undergrads at UC Boulder, and honoring the schoolgirl who named Pluto back in 1930. Together, the 7 science instruments comprise the most powerful set of detectors ever sent on a first flyby of any world in our solar system. But their innovative and highly miniaturized design means that even when all are operating, they draw less power than half a 60-watt bulb, and they're intended to work together seamlessly. After building comes testing, but always with an eye on the clock and the calendar.
It's very, very important that we launch in either 2006 or 2007. We have to make that deadline.
If you want to fly to Pluto on the quickest route, you need Jupiter in position. And that means we have to launch in January of 2006.
It feels a little bit like being strapped to a train going 500 miles an hour.
The test program involves teams of engineers at Johns Hopkins APL and then at NASA's Goddard Space Flight Center.
Once we launch this, we can't go after it with a screwdriver. We can't go fix anything that isn't working.
We make sure that we carry plenty of spare equipment on board the spacecraft. If our main computer breaks, we have a backup. If our main transmitter breaks, we have a backup.
One of the things we do is we put the whole spacecraft on a gigantic vibration table, a paint shaker, and shake it. And then test it after that, and shake it again and test it again. So that's what we're doing from now until launch.
Along with testing the spacecraft, New Horizons needs to train and test its human operators. And for a mission planned to reach Pluto in 2015, it's important to have young people on board early, so they'll be around at close approach.
It's good that we can do that, so they will have both the time, the focus to stay with the mission over this long period of time.
Many of the faces you see around Mission Control in 2004 and 2005 are young and enthusiastic spacecraft engineers.
Normally we're focused on subsystems and instruments in the spacecraft surviving that duration, but for people we have to have a longevity plan.
They'd be committing the prime of their careers to this mission to Pluto, knowing they'd be a decade older when New Horizons reaches its primary target.
The ability to practice things in those years far out there are all part of the planning now to assure mission success then.
How old are you going to be? In 2015? I don't know, somewhere in my 40s. Oh, and you're a youngster. Yes.
In late 2005, the action shifts to Cape Canaveral. New Horizons may be light and relatively small, but launching it to Pluto requires America's most powerful rocket, the Atlas V. New Horizons will be traveling so far from the sun that solar panels wouldn't be sufficient. So the Department of Energy delivered an RTG that would power the Pluto mission by turning heat from the radioactive decay of plutonium into electricity. Working round the clock, they arrive at Pad 41 before dawn. On behalf of NASA and the entire New Horizons team, Stern wanted to be the last to bid the spacecraft bon voyage before closing up the hatch. On January 19, 2006, after 17 years of planning, building, and testing, a picture-perfect launch that thrilled onlookers in Florida and the mission operations team back at Johns Hopkins in Maryland.
We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
Despite immense technical and timetable challenges, the mission had made its window and was on its way. New Horizons' velocity at launch was the fastest ever, traveling almost 60 times faster than a jetliner. In just 9 hours, it passed the orbit of the Moon. Apollo had taken almost 10 times that long. 1 year later, a slingshot gravity assist from the giant planet Jupiter provided another 2 kilometers per second boost, cutting travel time to Pluto by 3 full years. But this was more than just a jump in speed. The Jupiter flyby was a scientific dress rehearsal for Pluto. New Horizons instruments returned detailed images of Jupiter's clouds, moons, and rings.
Oh, wow, look at that.
Then it was off across the empty ocean of space, with no new land in sight till Pluto in 2015. The spacecraft had been tested and passed with flying colors. Now it was time to test the humans and the ground systems. July 5th, 2013. It's day one of a 9-day encounter rehearsal.
The main success criteria for this rehearsal is for the spacecraft to flawlessly perform its activities as if it were at Pluto, with everything the same, except that Pluto's not there.
The dates in 2013 were carefully chosen so that Earth received times would be identical to those for the real encounter in 2015. Mission managers wanted scientists and engineers to experience the stress of time-critical 24/7 operations expected for July 2015.
We're flying by an object that is a huge distance from Earth, and we're trying to hit a box that's 100 by 150 kilometers wide. And that then leads into maneuver planning and trajectory control needed to thread that needle and hit that small box. It's way the heck out there.
This rehearsal would actually be uploading commands to New Horizons to instruct the spacecraft to run through the exact same set of observations as in 2015.
There definitely is an element of risk involved, but from one standpoint, if you didn't do any simulation with the real spacecraft at all, you could argue that could pose more risk because you don't want such a critical activity only being done once on flight.
Those are all invaluable to get us ready and practiced for the one and only shot we'll have to explore the Pluto system.
We've been waiting 12 years since we wrote the proposals to do this rehearsal. It's the last big step before we can do the encounter.
We think that we are about 10 million miles out from Pluto and closing.
But so far, so good. We're off to the races. Today is our 2,724th day in flight. This has been a long time coming, literally. I only want to say thanks for all the work. Let them eat cake.
July 12th, 2013, standing in for July 14th, 2015. This is it, a minute-by-minute simulation of Encounter Day. It's make or break.
Well, it's the most important because we've best been spending the 24 hours of the most intense activities that we've been running on the spacecraft, and this is the longest that we've been out of contact since we've entered encounter rehearsal.
This may be a rehearsal, but New Horizons has been firing its thrusters and spinning in space, identical maneuvers to those planned for 2015. On Encounter Day, the spacecraft will be too busy taking data to send back images. That's why its first simple "I'm alive" message will be so important.
Sometime within the next minute, DSS 43 should lock up on the signal.
We're good. We're nominal. Spacecraft's nominal, and it looks like all the observations that we had planned between the last track and this track happened.
So this gives us good confidence that at least the spacecraft has been performing all of those twists and turns that we've been anticipating it to over the last 7 days.
I like to say that at the flyby, I don't want to be learning anything about the ground system or the spacecraft or the team. I want to be learning only about the Pluto system.
No spacecraft has ever been to Pluto, nor will ever go back in our lifetime.
Pluto is every child's favorite planet. You know, you ask anyone under the age of 6, they're going to say Pluto.
We don't exactly know what Pluto looks like, but it looks very exciting from the images we have from the Hubble Space Telescope so far. We really can't wait to get there and see what it actually looks like. So if anybody says that Pluto is boring or not important, no way.
Before New Horizons arrives at Pluto, most everything we think we know about the planet and its moons is up for grabs.
Virtually every place we've sent a spacecraft on a first reconnaissance mission like this, that we find out that our Earth-based notions were flat wrong. So I'll tell you what we expect, but before anything, what we expect is to be surprised.
From the 1990s through today, Stern has been consistent in avoiding speculation.
You get the same answer everybody's gotten from me for almost 20 years. I don't make predictions. except for one. My best guess is we're going to find something wonderful.
But in the final months leading up to the July 2015 encounter, it's hard for most humans not to imagine what we'll see. Many planetary scientists, like Paul Schenk, base their expectations on what we saw when Voyager 2 reached Neptune, and specifically as it flew by its moon, Triton.
Voyager was a 10-year-long exploration of the outer solar system, and every time they got to a planet, it was basically the first time anybody had really seen those bodies. So when they got to Jupiter, they were greeted with enormous surprises. The erupting volcanoes on Io were just completely unexpected. And so when they got to Uranus, there were more surprises. The exotic trains of Miranda and Ariel, for example, were not expected. So by the time they got to Neptune, they were kind of accustomed to the idea that they were going to be surprised. And sure enough, Triton completely blew them away.
Bonnie Barati was at NASA's Jet Propulsion Lab as the first images of Triton, a moon of nearly 1,700 miles diameter, came down.
Triton was almost a twin of Pluto. It's about the same size, about the same brightness.
Originally, Triton was probably a Kuiper Belt object, just like Pluto, floating around in space, but then it got too close to Neptune and it got captured by Neptune's gravitational field.
Recently, Paul Schenk enhanced the original Voyager data to create this detailed flyover of Triton.
It has odd patches and odd blob-like features, kind of like amoebas crawling around on the surface. Triton has very few impact craters. Its surface is extremely young geologically.
And it actually has geysers spurting material off into space.
Here is a body that is hundreds of degrees below zero. So cold, it's forlorn, it's barren. We just didn't expect to see this activity on Triton. It was quite a surprise.
If you just assume that Pluto was going to look exactly like Triton, which is the most similar object we know about, then you might expect to find a very interesting body.
But Triton is not the only dynamic ice world in the outer solar system. 16 years later, the Cassini spacecraft sent back images of Saturn's moon, Enceladus, about 300 miles across.
This is a tiny little moon, and Enceladus is actually a winter wonderland. It's very bright. It reflects almost all the radiation that falls on it, and it has these huge ice volcanoes spewing out from its south pole.
And Enceladus is continuously giving off puffs of water vapor, and so if you start to see puffs of water vapor coming off Pluto as New Horizons gets closer, that would be exceedingly interesting.
But what forces can power volcanoes in the deep freeze of the outer solar system?
Triton and Pluto are both balls of ice with presumably rock in the center, and so one of the sources of energy is radioactive decay inside the rock, which gives off heat, just like the Earth is heated. If you just let Pluto sit there and pump the heat out of the rocks, you generate enough energy to melt a couple of 100 kilometers worth of ice. It's still possible to have an ocean beneath a relatively thick ice shell. The ice shell might be 100 miles thick or so. Over billions of years, the ice shell gets thicker and thicker and thicker as Pluto cools, and as it does so, it squeezes the water underneath, and if you squeeze the water too much, then it may well actually create fractures and the water could jet out to the surface.
When you're going out to the edge of the solar system, you kind of have to expect some surprises, and we're going to see them at Pluto as well.
Just as Triton and Enceladus were mere dots before spacecraft reached them, until now, Pluto has been an astronomer's planet. That's about to change.
We are going to start off as astronomers, and we'll be using astronomical tools to try and sharpen up our images and pull every last little bit of detail out of these fuzzy blobs. We gradually turn from astronomers into geologists as we get closer and it becomes a real world.
Jeff Moore was in the room at JPL as those Triton images came down, but he also enjoys field work and thinks we'll recognize some similar planetary processes at work on Pluto as back on Earth.
So I'm a geologist, and although we don't expect to see oceans on Pluto, there are common processes which operate on this planet, which are likely to operate also on Pluto and its moons.
While the scales are very different, erosion shapes landforms here on Earth and all across the solar system.
There are these little finger-like projections that are formed by the process of erosion, where wind and water have sculpted this landscape by taking advantage of small differences in the strength of the original rock, creating large, huge, fantastic landscapes, such as on Jupiter's moon Callisto, and we can anticipate that we may perhaps also see landscapes like this on Pluto and its moons.
Pluto's 248-year orbit is more eccentric than our solar system's terrestrial and gas giant planets, greatly varying its distance to the Sun. But it's typical of many other objects in the Kuiper Belt and newly discovered planets around other stars. That, plus its highly angled polar tilt, combine to produce strong seasonal effects.
In fact, the seasons of Pluto are amongst the most extreme of any seasons on any world that we know of orbiting the Sun.
And those extremes may be one reason why its surface is also extremely contrasty.
Pluto is perhaps the most intensely bright and dark place that we've seen in the solar system. This dark surface collects more heat. It warms up like asphalt does on a sunny day here on the Earth. And if there were frost that had settled on this dark surface, they're being heated up and driven off, and the transportation of this material could also be creating wind. So you might see small dunes oriented along the periphery of the dark surface, showing this process in action.
For planetary scientists, color can be a clue to the composition of surfaces that can't be sampled directly.
On the Earth, these kinds of colors from red to dark gray are generated entirely by the presence or absence of rust. On Pluto, we see also these same ranges of colors from gray to bright white to yellow to red to black, but there it must be due to a completely different process.
At NASA's Ames Research Center near San Francisco, longtime Pluto researcher Dale Cruikshank and postdoc Chris Matarese conduct experiments to see what processes might create the colors we see on Pluto, starting with gases like methane and nitrogen and the extreme low temperatures we know are found there.
In our cold chamber, we can produce a thin film of ice and then after that expose them to a beam of electrons, which are charged particles, comparable to what comes into Pluto's surface from space. We find that when we shine ultraviolet light or electrons on simple molecules, before too long the simple molecules are broken apart, and by natural processes they reassemble into more complex chemicals. So far, the colors we make in the lab from irradiating these ices is fairly close to what we see on Pluto. There are tones of yellow, light brown, up through fairly dark red. And if we carry the processing by ultraviolet light to an extreme degree, the material actually turns black. And this is almost the color of pure carbon.
Seeing how radiation transforms simple ices into complex and colorful organic molecules should help interpret the close-up views of Pluto's surface that'll be sent back by New Horizons.
Color translates to the duration of the exposure of these otherwise colorless ices over a year, 10,000 years, 10 million years. That may in turn tell us more about the nature of the exposure of Pluto's surface and even the age of Pluto's surface.
Dale Cruikshank began observing Pluto back in 1976. Now, 39 years later, he's ready for its close-up.
We can say that Pluto is chemically active, chemically dynamic. We don't know yet if it's geologically active and dynamic, but that's what New Horizons is going to tell us. We've been surprised in that way before as we've passed other planetary bodies that we had thought were totally cold, dead, inert worlds, and find that there are geysers, there are ice flows, there are cracks, and all kinds of evidence for geological activity.
I can still remember the first time I saw Pluto in a telescope, and it was just a little dot that you could barely see. It will be amazing that within a period of hours, it will be transformed from this tiny dot that I studied as an astronomer to this huge geologic world that will be able to see volcanoes and faults and ices and mountains and craters. I mean, it'll be truly an amazing experience to see it transformed.
So, from sophisticated lab experiments, from exploring other worlds, and from applying insights from terrestrial processes, what should we expect when we get to Pluto in July 2015?
But the only thing that would surprise me would be if we turned out not to be surprised.
But enjoying the scientific surprises to come means avoiding dangers on the last few million miles to Pluto. That's next. December 6, 2014. In Mission Control, Alice Bowman and her team wait to get confirmation that New Horizons has exited what's called hibernation. For 2/3 of its 3 billion-mile journey, most spacecraft systems have been turned off, saving wear and tear on the science instruments. New Horizons sends a simple signal once a week just to say, "I'm still A-OK." Alice's team has a unique way of showing spacecraft status. When New Horizons is hibernating, their bear mascot is safely asleep. When the spacecraft wakes up, they put on its party hat. If all goes well, this will be the 18th time spacecraft and bear have woken up. But December 2014 is different. VIPs from NASA are on hand. 2 film crews document the action as Alan explains the benefits of hibernation.
It lowers our cost because we don't need to have people babysitting the spacecraft 24/7.
Outside interest in New Horizons is building. If all goes well, New Horizons will stay awake, flying by Pluto in July 2015, and then returning data until October 2016.
Copy that. Thank you, GNCs.
Tonight, data trickles in, and Alice has to wait to be certain New Horizons is fully awake.
We should be getting it momentarily.
Should be any minute now.
It's like watching paint dry. I figure if I stare at the screen hard enough.
And Packet 5 just came in. There we go.
There we go. PI, PM, Mom on Pluto 1. We have a nominal wake-up of the New Horizons spacecraft on its way to Pluto. We're ready for our next leg of the journey.
Was awake.
Our bear. He's going to be here for a while.
This is a watershed day. We have completed the cruise across 3 billion miles of space. The spacecraft is now awake.
Finally, after 9 years, I'm glad to see hibernation behind us and active ops ahead. On to Pluto.
But there are still hundreds of tasks to ensure a safe flyby in July 2015. January 27th, New Horizons has been sending back technical data and all seems fine. But today is the first time Hal Weaver and Andy Cheng will be seeing new science images.
I thought I saw it pop up here. Yeah, let's try that again.
Cheng is lead scientist for the LORRI camera.
LORRI is used for navigation to find the targets and to correct the trajectory so we get to the right place at the right time.
Voltages, currents, temperatures all look normal. No error messages.
This is it. Let's check out the very first images. And then Sharon, right there, peak pixel 55. That's right. Okay. All right, so there they are. Let's look at the whole.
For project scientist Hal Weaver, even the jump in size from 1 to 2 pixels was significant.
This is a real milestone in the New Horizons mission, the very first images of Pluto in the Pluto encounter year. Hadn't turned LORRI on, hadn't gotten any images since last summer, last July, but this is it. This is the start of it. How she blows.
We really don't know what we're going to see. That's what this mission is all about. What is the surface of Pluto really like? How big is it? What are the orbits really? So it's nothing but delightful surprises coming for us.
But some of the surprises may not be quite so welcome. As New Horizons gets still closer to the Pluto system, LORRI will be able to identify small moons and possible rings that can't be seen from Earth. John Spencer is leading the UHAZ campaign. UHAZ stands for Unknown Hazards.
We may find new moons or even rings around Pluto, and if we see anything like that, we're going to want to determine whether it poses a threat to the spacecraft, because if it does, if there's debris that we might run into that might damage or kill the spacecraft, then we want to evaluate that hazard and determine whether we should take any evasive action.
To find out just how vulnerable New Horizons might be to even tiny dust particles, the mission sent samples of spacecraft components to the White Sands test range. Technicians at White Sands set up gun tests to assess how vulnerable New Horizons' outer covers and cables might be.
We went to 2 facilities that could shoot things into parts, models of the spacecraft.
While the results might look dangerous, the mission has options to take evasive action.
One of the backup strategies we have if we feel we need to give the spacecraft extra protection is that we orient it so that the high-gain antenna here, which is literally pretty bulletproof and can protect the spacecraft, is going to be facing forward in the ram direction. This is ram in the sense of battering ram. It's a direction in which stuff will be coming at us and ramming into the spacecraft. And if that is facing forward, then any dust particles that hit the spacecraft are most likely to hit that antenna where they won't cause us problems, and only a small part of the spacecraft around the edges is going to be exposed to those particles.
That would protect the guts of the spacecraft, but limit the pointing of the cameras.
The cameras are fixed to the spacecraft, so if the spacecraft has to point in one direction, the cameras can only point in a limited range of directions. This limits the amount of times we can photograph the system as we go past, because we can only photograph objects when they're just in the right angle that we can look at them while protecting the spacecraft with the main antenna.
Another option is to take different trajectories through the Pluto system. That's called the Shabbat play.
Shabbat is the best acronym in the space business. It stands for Safe Haven by Other Trajectory. And it is the word we use to represent our backup plans at Pluto. The second Shabbat takes us much closer to Pluto, into the region where atmospheric drag depletes orbits of any debris, which we think would be the safest Hail Mary pass that we could fly if we have to do something different than the nominal. We are coming into the Pluto system with the ability, if we learn something we don't expect, to be able to make a change and get the goods.
But those decisions can only be made in the last month before closest approach, and there'll be limited time to evaluate the best options. So in February 2015, Spencer's UHAS team, including ring specialist Mark Showalter and postdoc Simon Porter, are running through a readiness test. Now they're on the clock and being scored for whether they can work through the calculations fast enough to decide on a trajectory correction maneuver that might prevent loss of mission. And that makes this exercise more critical than any that have gone before.
The difference between this and previous operational readiness tests is that this is where we have to demonstrate to the project and NASA that we can do this.
But the only test that really matters comes on July 14th, 2015. That one day will pay off 26 years of dreams and 9 years in flight. For the science team, the year of Pluto began with another meeting to review the latest data on the Pluto system and to hear updates on how the spacecraft was performing. Mission manager Glenn Fountain, who'd been with the project from its start, summarized remaining risks. Red boxes are possibilities that could kill the mission. But now, in 2015, there are more and more green boxes, risks that have been minimized.
Something that we haven't thought of still might happen, but I'm confident that whatever happens, whatever fate throws at us, this team will be able to resolve it, and we'll go on to get wonderful data when we get to Pluto.
We have a fantastically talented team of people who have worked very hard, and we've tested the sequences inside and out. And while there are always unknown unknowns, I'm very confident and really looking forward to the curtain rising.
Along with mind-bending technical details, there also was a sense of history in the making. To document the long years of effort to get this close to Pluto, the mission recreated a team photograph taken in 2004. As Glenn, Alan, and Alice had carefully planned back then, many of the scientists and engineers were still actively engaged in New Horizons and looking forward to July 2015.
We have worked hard to get a coherent team, because if you don't have a good team to operate the spacecraft, to do the planning, you will fail. And so we worked a plan early in the mission to have younger people with the right amount of experience to be on the mission. And it's just like watching your kids grow. It's like all of a sudden, where did the time go? You know, they are older, they're more mature, and they're now the very experienced veterans.
But the hard work of mission planning was by no means over, even this close to Encounter Day. While exploring Pluto in 2015 is exciting in itself, New Horizons was recommended in part as a mission that might continue on, farther out into the Kuiper Belt. That takes identifying potential targets now for a still more distant flyby, should NASA approve an extended mission. This challenging task was assigned to John Spencer, Mark Bowie, and a team of young postdocs. And like everything else about this mission, it wasn't easy. Bowie and John Spencer had been using Earth's largest telescopes in Hawaii and Chile, but even Earth's best couldn't crack this task.
But the basic problem is the Earth's atmosphere is just a mess at these scales. There's a limit, and that's what we've been beating our heads against. Now with time running out, we had to turn to Hubble. And so we sort of, not so jokingly, talk about Hubble to the rescue. Without Hubble, we would not have these objects.
Mark and his young collaborators came up with innovative search techniques using custom software.
What that does is makes the stars smear out and makes the Kuiper Belt objects hold still.
It's been a lot of work, but to do something as exciting as this has been just so much fun. I've been plugging through the data today because it's fresh data, and I just really wanted to know what the answer was.
Well, we would have been in big trouble if we didn't find the KBO in time. So there was this pressure, but honestly, we had the best people in the world working on the problem, and we did it.
And we just do the math, write the software, crunch the pixels, and then I create this graphic, and from that point on, it's what I call wetware. It's what you got in your head.
In reality, KBOs are moving against the fixed stars. Mark came up with a way of making them more obvious by flipping that around and making the stars appear to move, and any KBOs stand still.
Right in the middle, there's something that's just holding dead constant. And that's the Kuiper Belt object. You can't argue with that.
It was a high-tech variant of the approach that had been instrumental in exploring the Pluto system right from the start.
But at the core, it's a technique that hasn't really changed since Tombaugh's day. You have two pictures of the sky taken at different times, and you're looking for the stuff that moves. As soon as you see something real, there is absolutely no question about it. As soon as it flashes on the screen in just a millisecond, there it is, it's real, and you know, I've found another Kuiper Belt object.
But finding a KBO is only half the battle. Is it located where New Horizons can reach it with available fuel?
And once you have the orbit, and we know where the spacecraft is and where it's going to be, we can figure out how much fuel the spacecraft is going to need to use to get to these objects.
With more Hubble time, New Horizons got a pleasant surprise.
It looked like we might actually have to burn the engines to miss the object, which was a pretty exciting concept. You know, it's a good thing we looked, because you wouldn't want to run into one of these things.
These cold classicals, they're pretty much as they were 4.5 billion years ago. They're little fossils. That's incredible. We have no idea what they're going to look like.
So with potential targets found at last, it was on to Pluto.
I'm feeling pretty exhilarated at this point. You know, you're at the top of the roller coaster, you're about to go down that dizzying, thrilling ride into the system. Just seeing Pluto there getting bigger and bigger, it gives me goosebumps.
Today, we're only a few months away from the encounter. We're less than an astronomical unit, the distance between the Earth and the Sun, that distance away from this fascinating object. It's the last major body in our solar system that we really need to visit.
To be putting the capstone on the initial reconnaissance of the solar system, it's heartwarming, and it feels like something that makes a career worthwhile.
As spacecraft goes, New Horizons is a very small team, but still, we've been working on this for over a decade, and you add it all up, and it's about 2.5 million work hours to get ourselves to Pluto.
We have waited first the 4 years that we couldn't hardly think about because we were running so fast, and then it is, oh, we wait and we wait, and now we are ready to begin the encounter. We have had delayed gratification.
The year of Pluto is, simultaneously a beginning and an ending. It's an ending in that we are completing our objective. We're accomplishing the flyby of the Pluto system for the first time. But it's also the beginning of a whole new chapter for science, of really being able to explore these objects as the data comes down over a period of months. In bringing in postdocs and the younger scientists who, some of whom were in high school when we started this project, and now they have their PhDs and they are spectacular experts and very talented at what they do.
I was in preschool when Alan first started talking about a Pluto mission, and finishing high school and starting college when it was built, and in grad school for the cruise.
Having young people come into these programs, gaining the experience, they're going to be the next generation of explorers.
We've never been to a KBO. We've never been anywhere close to a KBO. This is the most unexplored area of the entire solar system, which is another way of saying this is the most unknown area that we as humans can reach with spacecraft.
We can't wait to get to Pluto.